Welcome to my class on soft computing. In this presentation, I propose to solve a problem, an interesting problem in fuzzy logic. The student is expected to have a basic knowledge on fuzzy logic and membership functions. This is a problem on compensation for professional engineers. So, the compensation for quality efforts in engineering does not have to be solely related to money. The reward structure can be public compliments, good grades, etc. Desired professional behavior can be hard work, good manners, and high productivity. The management perceptions can be whether the engineer is nice to have around and whether he makes the boss look good. The statement of the problem. So here we are given the relation matrix of membership functions relating management perception and engineer's behavior, RPB, and we have another relation matrix relating reward and management perception, RRP. So given these two matrices, we need to compute the relationship between reward and engineer's behavior, RRP. This can be done using MaxMin composition. The matrices B, P and R, that is, they are given like this. The engineer's behavior B equal to hard work, that is HW, good manners GM, and high productivity HP. The management perception will have two attributes, that is B equal to nice to have around, NHA, and makes the boss look good, MLG. Reward R also has two attributes, public compliments BC and good grades GR. The relation matrices. RPB relation matrix between perception and behavior, that is RPB, that is NHA, that is nice to have around, has a membership of 0.2 relating to hard work, 0.8 relating to good manners, and 0.7 relating to high productivity. MLG, that is makes the boss look good, has a membership 0.4 with reference to hard work, 0.5 with reference to good manners, and 0.8 with reference to high productivity. For professional behavior and management perception can be established by engineering staff and management together through a combination of subjective judgment, consensus, and normalization of possible values on the interval 0 and 1. The rewards are in the range of 0 and 1, where a membership value of 1 corresponds to a maximum public compliment, and the membership value for a good raise might correspond to 3.5%. Now, this is a relation matrix RRP, that is the relationship between reward and perception. So, the public compliment has a membership function of 0.5 with reference to nice to have around, and 0.9 for makes the boss look good. Then good raise is having a membership function, 0.7 for nice to have around, and 0.8 for makes the boss look good. reward R and the behavior of the engineer B is required. So this can be computed through a composition, and in this case the MaxMin composition is used. MaxMin composition is given R of xy and S of yz, then the MaxMin composition T of xz is given by T equal to R O S and T of xez equal to max with respect to y of min of R xy and S of yz. So now I show the matrices RRP and this is RRP, that is, I am showing it again. So here the first term is 0.5 and see the next matrix. And here this is RPB, that is matrix between perception and behavior, and here the first term is 0.2. So now see, I will show you a sample calculation. RRB of 1 1 equal to minimum of RRB of 1B and RPB of B1, giving varying values to B equal to 1 and 2. So max min of 0.5, 0.2 and 0.9, 0.4. Now see so here the first value is 0.5 and second value is 0.9, and see the first column in this one, here it is 0.2 and 0.4. So the first term in the resultant matrix RRB of 1 1 is max min of 0.5, 0.2 and 0.9, 0.4. So the minimum value of the first set is 0.2 and the minimum value of second set is 0.4 and the maximum of these two is 0.4. So the first term in the relationship between the reward and behavior obtained using MaxMin composition is, the first term is 0.4. Similarly, the other terms can also be calculated using MaxMin composition. So the result shows that for these data at any rate, it is equally possible to receive a reward through public compliments as through a good race. So that is, we are getting the same elements for public compliments as well as good race. So here is a note. So note that RPB is a 2 by 3 matrix and RRP is a 2 by 2 matrix. So the resultant matrix is RRP is a 2 cross 3 matrix which follows general matrix multiplication rules. So let's see a similar problem. So let small integers be defined as a fuzzy set A equal to 1, 1, 2.5, 3.4 and 4.2. So here 1, 2, 3, 4 are the elements and 1.5, 0.4 and 0.2 are the membership functions. Let fuzzy relation almost equal be defined as R equal to, here again 1, 2, 3, 4 and 1, 2, 3, 4. 1 is equal to 1, so it is getting maximum membership function of 1. So 1 can be almost equal to 2 with the membership function of 0.8. 1 cannot be equal to 3, so the membership function is 0. 1 cannot be equal to 4 and the membership function is 0. The other membership functions are also derived in a similar way. So given the above sets, given fuzzy A and R, the membership function of the new fuzzy set B equal to rather small integers can be determined by MaxMin composition B equal to AOR. So it is left to the student as an exercise. So the answer to this problem is B equal to 1, B equal to 1 0.8, 0.5 and 0.4 for the elements 1, 2, 3 and